Hello, everybody. Thanks for tuning in today. This is your host, Joe Langton with Automating Success. Today, I've taken on the show, and he is going to be a great guest. He's got some cool stuff that he's doing. And Tekin, why don't you go ahead and kind of just kind of tell the people listening who you are and what you're passionate about.
Of course, yeah. First of all, thank you for having me. It's a pleasure. So my name is Tekin Meriçli. I'm the co-founder and the CTO of Atlas Robotics at the moment. Um, Atlas Robotics is building autonomous forklift technology. Essentially, we are set out to build the best forklift operator in the world. And we can talk about the details of that, I guess, in the rest of the show. But a little bit of more detail, I guess, about myself would be, um, well, I've been working on robots for the past 2 decades now, a little over 2 decades. I've had the privilege of working on really, really interesting projects throughout my career, which started in academia and then transitioned to applied engineering and finally to entrepreneurship. And as I said, I've had the chance and privilege to work on and contribute to and even lead really high-profile projects intended for different use cases and applications, ranging from certain military applications to some industrial automation processes and agriculture, mining kind of applications, all the way to commercial stuff, including autonomous trucking and finally autonomous forklift. Um, I have a PhD in computer engineering, computer science, with a focus on artificial intelligence and applied machine learning and robotics. And that has been my career for the past, as I said, 20 plus years now. It all started with an interest in computers in my early childhood, thanks to my role model, my brother, who first fell in love with computers, and then our interest in computers slowly transitioned to interest in smart computers and hence AI. And then eventually that interest turned into embodied AI, i.e., intelligent robotics. So that's where we are today after maybe 30 years or so of working on computers and gradually transitioning to AI and then finally to robotics.
It's really come a long way, hasn't it? It's amazing to
Indeed.
see where things started and where we are, and then to actually think of how far we have yet to go, right?
Indeed, indeed. Yeah, the field is still in its infancy, even though a lot of people have been working on that cool uh, field for the past, I don't know, 70, 80 years now.
Yeah. So, you know, obviously you got us kind of up to speed with your background, where you got started, but what inspired you to do your current project? Making the best forklift operator there can be. What was the inspiration there?
Yeah, so maybe just to lay the foundation, I should highlight that as entrepreneurs, we are not really like solutionists, where we have a solution that we are in love with, and then we try to just push that solution out to the market, hoping that it will stick. We are actually uh, uh, problem solvers. And ideally, the problems that we try to solve are the problems that people are suffering from. So that's why we first look at the landscape and try to understand existing pain points in the world in general, and then see if we can find a solution to that pain and bring in technology, whatever is necessary, different parts of the technology, maybe put a system together to actually address that pain point. So it's never like a bit of technology first and then try to find the market for it, but first market analysis and pain identification, and then come up with a solution. So with the autonomous forklift project, the main pain point is actually there are three main pain points. The first one is safety. If you look at the statistics, you will see that unfortunately, even just in the US, every 3 days, someone dies of a forklift accident. Because nowadays, especially with the advancement of e-commerce and such, the demand is ever increasing. We are all used to clicking on some virtual buttons on our screens and expecting some stuff to show up on our doorstep. But in order for that thing to show up on our doorstep, it has to go through a bunch of material handling, transportation, logistics processes. And there are simply not that many operators who want to take on the forklift operator jobs. So because of that scarcity, there is a lot of pressure on the existing workforce, and as a result, they are strained. They are like pushed to their limits, and they are not living very, very healthy lives because of that, and because of, again, lack of sleep, overworking, and whatnot. Accidents can occur, which also result in a bunch of costs, as you can imagine, damages and insurance and such. The other thing is speed in general. So there are automation solutions out there in the world, in the logistics world as well. But majority of those solutions are not matching human flexibility and speed and agility. So they are rather slow, rather clunky, and also from a cognition perspective, from an intelligence level perspective, definitely not matching the human level. Because when you actually look closely, you will see that what human forklift operators on a day-to-day basis do is a lot more than driving the forklift from point A to point B. It's actually a lot more about handling task variability at the endpoints. Essentially, like when you are picking up a pallet from, let's say, a trailer or something, every pallet is going to be a little different. Some of them will be damaged, some of them will be badly shrink wrapped, etc. So there's that kind of task variability that challenges the robot's perception and cognition capabilities. And also on the other end, when you manage to actually pick up the load, when the warehouse management system tells you to get that load to somewhere on the shelves, there is a discrepancy between what the warehouse management system thinks it knows about the layout of the warehouse versus what actually the layout looks like. So when you go to the suggested destination, you may find out that that location is already full. So you have to be creative and think on your feet to find an alternative solution and report it back, so the warehouse management system can keep a relatively up-to-date picture of the layout. So today's robotic solutions fail on those kind of things. Like they are maybe okay with going from point A to point B in a rather slow fashion, not comparable to human speed. But when it comes to handling task variability and exceptions in the workflow, they unfortunately fail. So with Atlas Robotics, that's one of the main things that we would like to address. Essentially, build a technology that is as capable, as flexible, and as fast as a human operator, and can also handle task variability at each end of the workflow.
So would you say one of the things that makes workflow complicated right now is because maybe there's a mix of humans and automation doing it? Like it sounds to me like you just broke that down and said, okay, yeah, takes point A to point B and there's something in its point B spot. Is it because some, human being put it there, but then the automation has to figure it out? Like I would see eventually in the perfect world, if the automation does it all, the automation is tracking the space, tracking point A to point B, right? Is that kind of where we, one of the things that is making the adoption of this a little more difficult than it will be in the future?
Yeah, actually, that's a great point. And that also applies to a more general, like autonomous vehicle problem. Maybe we can talk about that as well. Like when you actually imagine a world where everything is handled by mobile robots, smart mobile robots, all the vehicles are replaced by robots, and there is no like a hybrid configuration, if you will, where some of the vehicles are driven by humans, some of them are robots. Then yes, I mean, ideally, a completely computer controlled and AI controlled system would actually be able to get things done perfectly. But unfortunately, the moment that you break that closed world assumption where everything is under your control, that whenever you have an interface with the outside world, essentially, where you ingest something that is outside of your control, that kind of assumption and that idealistic view and picture breaks down. For instance, again, with logistics, everything actually gets transported on pallets. There are like 5 billion pallets in the world in circulation. So you essentially exchange pallets with different manufacturers, etc., and which makes some of those pallets essentially commodity and not being controlled by your system, right? So the moment you ingest them, that uncertainty starts to creep in. And the other end of it, even if you are kind of controlling your entire facility, then you are pretty much forced to build your entire facility ground up with it being like operated by robots exclusively. Like for instance, some Amazon warehouses were built from ground up so that the robots could actually operate in them. There are 750,000 Amazon robots working, like traveling on those grids, carrying shelves around and all that stuff. But those facilities are purpose-built for robots. Whereas majority of the facilities, manufacturing plants, warehouses, etc., the legacy world is not essentially built for robots. It's built for humans. And as a result, if you want to actually improve operations in the existing facilities, you have to devise some form of a hybrid way and start injecting automation to existing facilities in order to avoid incurring additional capital expenditure and infrastructure investment.
Yeah, no, I think that's, a point sometimes people forget, even when they're talking about automatic vehicles, is, in my mind, and you can expand on this if you want, it's like if something was going to automatically drive, it almost needs its own lanes, and then it needs to like alert you that you're entering back into the real world of crazy drivers and wake up and take back over because a lot of times even when we're driving ourselves, people cut us off. All sorts of bad things happen. We adapt. We deal with that in real time. But then now with automatic vehicles, those accidents happen. It's like people always want to blame the automation, and it's like no, it's bad drivers, and they've got to interact with it. So, it's like I'm sure you agree with that, but.
Yeah, no, absolutely. And it's you can think of it as like a continuous spectrum between, again, like everything being closed world and controlled and as a result, not flexible, versus everything being extremely flexible and adaptable to the existing conditions. Again, from the world of autonomous vehicles and trucks, I can give another example. So actually, it was my brother, my co-founder and long-term collaborator, as I said, was having this conversation with a gentleman at a conference about autonomous vehicles. And in our previous company named Locomotion, we were building autonomous truck convoys, still kind of keeping human in the loop, but essentially automating half of the equation while the human driver in the front vehicle would lead the convoy, the rear vehicle, the follower vehicle will be autonomously following the lead. That was our model. And when he was explaining this model to the audience, and after I guess the talk, one gentleman started hypothesizing about what if scenarios. Like, what if those vehicles actually had like traveled on HOV lanes? Okay, great. And but other vehicles may enter the HOV lane as well, right? So that really does not save you from detaching yourself from the rest of the world. And then he said, what if we had like barriers and all that stuff? Okay, then you're essentially limiting your flexibility. And then my brother further kind of examined and said, what if we actually laid like steel rails and then put a bunch of those vehicles on the rails? Then all of a sudden, guess what? We are actually calling that a train, right? So you essentially take that kind of flexibility away and turn it into a very rigid solution. So that's what today's AGVs, automated guided vehicles in the logistics industry actually do. Like they have their predefined paths, either drawn as a line on the floor or like a magnetic tape or whatnot, and they can only follow that path. They cannot go outside of that path. Anything that the world throws at you outside of those boundaries, the robot gets confused and stops. And it's not a flexible solution. As a result, its value add is relatively limited. That's why it's not a super kind of sought after solution. Whereas what we are looking to build with Atlas Robotics is like going to be any other human operator. You just inject into your existing workflow, and it adapts to the environment. It can work with the other human operated vehicles. It can understand what's going on around itself, understand the traffic and right of way and whatnot. And also, as I said, handle tasks variability. So it can be part of your organic workflow instead of requiring very rigid and segregated, if you will, workflows and routes.
So what's your go to market strategy with this? Do you sell them directly, or do you put them out in like a subscription model? I'm sure there's people hesitant to, how they keep running. So do you kind of make it a bundle, or how do you go about that?
Yeah, so our preferred model is as a service, robotics as a service model. So we essentially, as I said at the beginning, we would like to solve the problem for our customers, not necessarily sell them robots that they will use for a while and then put to the side only to collect dust. But if they have pellets to be moved, we move those pellets, and it should be completely transparent to the customer how we are actually solving that problem with how many robots and all that stuff. As long as we don't create additional headache, which is the last thing that we want for them, our job is to go and move their pellets and improve the efficiency and optimize essentially their operations while reducing their costs. Definitely making the operations a lot safer compared to human driven operations, and as a result, reducing all the costs associated with the safety processes as well.
So how many units do you guys have out in operation?
Well, we are a young startup. At the moment, we have only 5 units, 3 of them deployed at a customer, or about to be deployed, I should say, in preparation to be deployed. And 2 of them are still kept as a testing unit. And we are also looking to expand our footprint in the US. So the current customer is in Turkey, actually, my hometown. And nowadays we are looking to expand our footprint in the US and hoping that we'll have reached about 50 robot kind of deployment volume by the end of this year.
Fantastic. Yeah, I mean, listen, having 5 is 5 more than most people have, right? So
Indeed.
I would say you should be very proud of that,
Thank you so much. I appreciate it.
Yeah. So okay, so obviously you had experience in locomotion. So how did your approach have to change, obviously doing the forklift stuff? Because I'm sure you don't have them following each other. It's they have to do it themselves. So how did that change? What were you able to bring from one endeavor to the new?
Yeah, at locomotion, as I said, our approach was a human in the loop approach, even though the follower vehicle was a completely autonomous vehicle. It still received, if you will, its guidance from the lead vehicle. So the lead vehicle would do something, and the follower vehicle would perceive it through its own sensing and process it through its onboard computing, and then come up with the best set of actions to follow its leader as best as possible, while also reacting to its immediate surroundings. So as you said, when it comes to a forklift, we don't have that kind of a convoy configuration. The vehicles are individually autonomous and independent. The main difference between the 2 applications and use cases is how much kind of edge cases, if you will, or interesting things that you would expect from 2 different worlds, and also what kind of safety and technology sophistication levels that you are looking at, again, for both applications. On the one end, we are talking about 40-ton trucks traveling at 70 miles per hour in a public traffic environment where there are many thousands of other agents that are completely outside of your control. Some people drive really crazy. Some people are kind of okay. and there's the weather condition aspect, right? So it may rain, it may snow, the sun may actually blind your senses momentarily, etc. So your autonomous vehicle needs to be prepared for all of those kind of cases and their combinations. And that's why the combinatorial aspect of it makes it a huge and very, very challenging problem. And that's why, even though autonomous driving concept has been around for over 50 years now, we at best still have advanced prototypes, but we don't have any reliable, scalable products. Another thing, again, on the trucking side of things is that if you are building something that is going to be operating without any human fallback or assistance, you have to have certain redundancies built into your system architecture. You need to have like redundant steering systems. You need to have redundant braking system. You need to have redundant power system. If the primary unit fails, your system falls back to the secondary unit and then kind of gracefully degrades the entire system, maybe as the vehicles are pulling over to the shoulder. Whereas for a forklift application, they are not nearly as fast. They are never traveling at 70 miles per hour. They don't get exposed, especially the ones working indoors. They don't get exposed to different weather conditions. They are never like rained on. I don't know. They don't deal with a blizzard. They don't deal with direct sun light kind of blinding them, etc. And they are traveling a lot slower compared to a truck. So your stopping distances and your fault reactions are completely different. I mean, in the worst case, if your autonomous forklift somehow encounters a problem, the best thing you can do is just like stop it in place, and then your service crew can handle it. That put it to the side and then handle it. You can deploy another robot in its place, and the operations can keep going as that broken down robot is being replaced. Whereas with trucks, you definitely don't have the option to stop in lane. Like stopping in lane is one of the most dangerous things that you can do. So you actually at least have to get off the road, and your vehicle has to be intelligent enough to get off the road. And as I said, it has to have enough kind of redundancies in sensing, computing, and steering, and braking, and whatnot, to be able to operate the vehicle during that time where you are kind of doing your minimum safety maneuver, or minimum risk maneuver, as it's called in the industry, MRM. So there are those kind of differences that actually dictate what kind of sophistication levels you should be implementing and what kind of worst case scenarios you'll be looking at if something goes south. So the stakes are, the height of the stakes are completely different in the two use cases or two applications.
Yeah, personally, I sometimes wish we never even though I shouldn't say this because so many people I have on the show have already done what you've tried to do, because there seem to be all sorts of funny money and fundraising that was done and successfully accomplished to do automatic driving. But as someone that's in the automation space myself, I love to drive and I love automation, but I would never want my car to drive me because it's one of the freedoms that I can't imagine ever losing. I love it, right? And I always wonder too, because people always look at automation from a hardware level, but they never think about where the computing is happening in the cloud, some server, someplace. So then I've always wondered with automatic driving, you don't know when people are going to decide to get in their vehicles. So now you have automatic vehicles, and now you've got this big data load. You have to do something with all of it, right? Whereas with doing something that you're doing, the business can say, we have so much, we have X amount of product coming in the door, X amount coming out. We're going to need this much. And you can build your cloud or however you're doing the computing with these things, right? And maybe it's all on board. Might be a little bit different than the stuff that I'm using, but I think it's something that people never think about. And I don't know if you want to expand on that, because I do believe it's something that not only are you in a controlled physical environment, but you can actually control how much computing needs to get done based on their projection.
Yeah, so for our applications, both for locomotion and for Atlas Robotics, the computation was on board because, again, due to the especially for outdoor driving, due to the high-speed nature of the task. Simply like the laws of physics don't work when you want to transfer that sensor information
you can't have the
to
latency.
a central server and then have the computation result back. That the latency does not work, and that's why, unfortunately, there has been a lot of attempts and successfully raised some money as well at teleoperation, remote operation of like vehicles, like trucks and all that stuff. Back at Carnegie Mellon, when we were a special faculty there at the National Robotics Engineering Center, we had some military programs where we built actually like teleoperation systems for military unmanned vehicles, and we were able to control, let's say, a rover in San Diego from DC over like dedicated military satellites with minimum latency. But even then, if you wanted to directly control that vehicle, you would actually suffer from that round trip latency. Again, this is basic laws of physics. You cannot really defy those. And to overcome those kind of problems, we had to create some smart solutions where we would actually have like a digital twin of that vehicle on the control side, on our side, where we would command that ghost of the vehicle, if you will, and generate the trajectory, and then send the trajectory over to the vehicle for the vehicle to execute that trajectory autonomously. So the vehicle had to be intelligent enough to take higher level commands and directions and then execute it by itself. But even that demonstration was done in a kind of a off-road environment where the robot was the only moving thing around. Because when you introduce other agents as well, all of a sudden you are changing the speed at which the world actually changes around you, and what kind of differences you see like at every new sensor frame that you receive from your sensors. Let's say you have like a 30 frames per second camera. In one frame you see something, and there's another vehicle coming at you, let's say at another like 70 miles per hour, and the relative speed between the two vehicles all of a sudden would be, let's say, 140 miles per hour, right? So that translates to roughly 60 meters of difference like every second. So which means that at a 30 frame per second camera rate, like every other frame, the two vehicles would be like 2 meters closer to each other. So it's a huge displacement in the real world. And if you introduce, let's say, 1 second of latency, like all of a sudden, you'll be seeing things that are actually like that were 2 meters behind when you receive the sensor information. And by the time you send your command, it's already going to be obsolete, and you will likely actually crash into things. That's why teleoperation for high-speed applications in a dynamic environment will never work due to basic laws of physics. So when it comes to, again, you loving to drive your vehicle versus a computer actually driving it for your stead, if you remember the very first thing that I said at the beginning of our conversation, we actually, when we are approaching a problem, we look at the business case of it. Like if it actually makes sense from a business perspective, if that problem wants to be solved from a business perspective, then we would like to go ahead and try to solve it. So when we were starting Locomation back in 2018, that's what we did, because we could have started another robotaxi company as well. But we actually took our time to do basic business analysis and unit economics and all that stuff, only to arrive at the conclusion in a few minutes, literally, that robotaxis don't make any sense because they are super expensive. And what is the real use case? Like even if we had robotaxis today roaming around, do any one of us want to actually ride in a vehicle at any time in any given day? Like there are peak times where you actually need your vehicle to go from point A to point B, from your home to your office and back, from the office to home and grocery store and back and all that stuff. But you would rarely want to actually hop on a vehicle at, I don't know, 3 a.m. in the morning and just like take a ride just for the sake of it because the vehicle is available. So which means that those robot taxis won't be 100% utilized. And when you also add to that equation, like who is going to actually take care of them? Who is going to make sure they are always calibrated? The sensors are always clean. They are always like in tip-top shape. Everything is well maintained, etc. Who is going to clean the interior if some accident happens? So if there are taxis, we know what kind of accidents could happen. So if you actually add all of those potential cost items, all of a sudden, your unit economics actually start breaking. So you will have to have millions of those vehicles with 100% utilization running like 24/7 for them to actually generate some meaningful revenue / profit. So just at that kind of basic unit economics level, the model breaks down. So that's why robotaxis don't make any sense. Unfortunately, after having spent like billions of dollars, some companies are realizing that maybe it wasn't a good idea after all, and they are kind of pulling out of that space. We've seen in the past 2 years or so many robotaxi companies kind of stepping down and closing shop, unfortunately. So yeah, I think it all has to start with the business case. Are you generating any meaningful value so that you can actually ask a little higher than the value that you are generating so you can make a profit, right? So, but when it comes to trucking, there is an actual need because even 5, 6, 7 years ago, we were hearing about driver shortages. We were hearing about the aging driver population and the new generation not wanting that job because it's a very tough job. I mean, especially for long haul driving, you are away from your family and friends like weeks at a time. It puts a lot of stress on your lifestyle burden. There are a lot of like obesity and heart diseases among the long haul drivers because they eat very unhealthy like fast food and they're not taking good care of their hygienes, etc. So lots of problems, not to mention any kind of divorce cases and not because of being away from your family for that long. So long story short, it's a hard life and not the new generation does not want it. And as a result, there is no new drivers coming into the equation and that driver shortage gap keeps increasing. But as I said, the demand never stops, right? We keep clicking on those virtual buttons on our screens and asking for more to be delivered to our doorstep. And guess what? Trucks actually deliver that. So there is that kind of need, but not supply in terms of the drivers. So a form of automation solution would definitely help that industry. But I don't think the same automation solution will help taxi industry. I mean, we already have a lot of human-driven taxis, and even they are not 100% utilized. So.
Yeah, and I think with the trucking space, obviously, as they're trying to not have people fall asleep at the wheel and limit accidents, the long haul truckers complain they can't make enough money in the current market with the current market pricing once they couldn't do a 24-hour haul and they have to stop and sleep because they don't get paid to sleep, and so I mean, I think there's another reason why there's a need there, and I'm going to hit a few points because I want to expand on those. I watched a show once. I was at my daughter's volleyball tournament. You brought up something with the two vehicles moving at each other and how just in the computing time, how much closer they are to each other with every second or whatever. You likely already know this, but a lot of people listening maybe have never heard this before, but I watched this show about how the best athletes in the world train in our brains. We actually see into the future. We're not computing anything in real time. I mean, even as you shake your head, I'm assuming you're going to shake your head at me. Okay. And then it happens, right? So it's one of the things that's interesting as I look at the automation space and wonder with, some of the AI stuff coming out now, it will actually be able to start to model into the future based off of an assumption like our brains do. Because when I talk to people about automation and they see, I don't know if you know about us, but we do like robotic picking of golf balls and cutting of grass and stuff. And they'll see the robot, like it'll lose RTK and it just stops moving. And they're like, oh, that doesn't make any sense. But it's like, because it's not seeing into the future. It doesn't assume RTK will be back in a half a second. It waits for it, right? Whereas human beings, we assume things. Like we assume someone's going to make a left turn, even if they don't have their turn signal on, because we're like, assumption tells me this guy wants to go left, And that's what makes us human beings just think. I mean, evolutionary. It's fantastic, right? So that's something I also wanted to comment on because do you have anything to add to that? I mean, how far into the future do you think we are to where we're going to allow the robot to predict the way
Yeah.
human beings do?
Yeah, so that's a great point, and I guess what you described with the sports analogy is what I know as a term. A hockey player does not skate to where the puck is, but he skates to where the puck will be, right? So I
Correct.
think that's
Yes.
that's that's true for any kind of business as well. So you should not be actually reacting to day-to-day stuff, but you should actually try to predict where the trends will go and then try to skate there so your business actually meets that trend at the right time and you kind of take off from there. When it comes to robots and predictions, I mean, there are already methods for predicting and filling in the blanks and kind of making up for missing sensory data. That's like I'm sure you are familiar with the concepts like sensor fusion and Kalman filters and such. So essentially, you take in a bunch of raw sensor data and then kind of fuse them together. And based on your also internal models of like how your robot actually moves and what it has observed so far, you can then, to a limited horizon, try to predict how things will look like around you if you actually keep doing what you are doing, or if you execute the plan you have in mind in terms of like, I don't know, following a trajectory or something. So there are already some methods, pure mathematical ones, analytical ones, as well as some machine learned ones as well, to predict your robot's own state, its sensory input, as well as the other agents in the environment, like how they are actually going to behave. You also gave an example of, okay, this guy is most likely changing lanes, so I should actually behave, act accordingly or react accordingly. So there are ways, but as I said, to a limited horizon. The reason for that is when you extend that horizon, all of a sudden, you can think of it as like, let's discretize it for a moment and think of a game of chess. A game of chess is discretized, right? So you have the kind of discrete moves, and as I don't know, novice, let's say, players, you can try to predict what your opponent will do up to like the next move. If you are a little advanced, you can maybe predict the next 2 moves. If you are like a grandmaster, you can predict up to 10 moves. But when you say up to 10 moves, with all those combinations, it actually means, I don't know, maybe a few hundred potential board combinations. So when you bring the problem back to continuous space, where like robots are moving in continuous trajectories and such, if you expand that time horizon of prediction, a second into the future is like relatively easier to predict, again, with the known laws of physics, with the known vehicle models and all that stuff. But 30 seconds into the future is almost impossible and I think unnecessary to predict as well.
I agree with you. And honestly, probably the only thing that's necessary is what is, in order to make humans look at them and say,
right,
yeah, that makes sense to me. We have to figure out a way to get them to see as far into the future as we do, which from what I've seen, it's about a second. It's like, they even say like in playing like table tennis or ping pong, you should never look at the paddle, you should look at the person's elbow. So good ping pong players are actually focusing on the elbow because they can predict where the ball slices across. Whereas if you look at the paddle, you never know. And that's how we're doing it. So stuff like conversations like this always are intriguing to me. And the reason it interests me so much, talking about having a problem to solve, is as I look at Atlas Robotics and you keep telling me, okay, we see a problem with forklifts, we want to do that. And then you brought up, okay, there's taxi cabs getting out of the space. It's like, I want this podcast to get shared to say, okay, take that technology and give it to me in the snow removal industry, because it's the same problem. It's like, as we speak, we had a snow event last night. I have 150 people that work for me. And it started snowing, and this is what happens in that industry, by the way. It started snowing. I'm telling you this because maybe you'll make me a system. So it started snowing, like we had a salt event the day before. Then I've got people working on equipment, keeping it fixed. Then it snowed like Thursday night. We got 2 inches. They did it all clear. There was a 3 hour, 4 hour break. It snowed again. Point is, I, and it sucks to say it out loud because my insurance company would probably be pissed, but it's like I'm basically trying to figure out how to let people get 4 to 6 hour windows of sleep because there's 50 hours of snow in the forecast in a 56-hour period, and the consumer, they're more worried about slip and falls than they are about employees in the snow removal industry getting sleep. And you can try to be a leader and say to your customers, hey, my people need sleep to protect your people. And they go, I don't care. My customers are slipping. Get back here. Right. So it's a real need. And so to expand off what you said, there are so many places in the world that have these total business cases that would support the need for automation. But then if I talk to a customer and say, hey, I'm going to figure out how to automate this, the next thing they say to me is, yeah, but can it be safe around the people that work or shop here? And it's like, well, it would be much safer than the person that's been behind the wheel of that for 13 hours.
Yeah, yeah.
When the human being maybe starts to make assumptions 5 seconds into the future when they should only be 1 second just because they want to get done. Right. So sometimes, but how far out do you think? I mean, you brought up things like snow and blizzards and you did the locomotion. So, how hard will it be for something like this to get into the industry that I love? And it's the first business I ever started with snow removal. What do you think? How far away are we from me getting my dream?
There are definitely bits and pieces of technology and nuggets that you can pull from the autonomous vehicle research and development. Again, thanks to all the investment money and thousands of hours, man hours of like every single person worked on the problem so far. I don't think like it's a lost case. Maybe the timing is not right. Maybe again a more beneficial and actual like value creating use case as your business is can be thought of, and those technology nuggets could be applied to. And I would also like to have a conversation around those things because I have some similar ideas. I'm sure we can actually exchange some thoughts on that front as well. But even the basic bits and pieces and nuggets available that came out of that many years of autonomous vehicle R&D would definitely benefit your approach, your robotic snow shovels and whatnot today. So you don't actually have to wait for another decade or two to make that a reality. Of course, when it comes to snow and such, those kind of adversarial conditions, there are a few additional things that you need to think of. I have direct experience again from my previous role at Carnegie Mellon's Robotics Institute. Essentially, believe it or not, I was one of the lead engineers of an FHWA snowplow truck kind of augmentation system project where we built a semi-robotic system with the sensors and a human machine interface display to assist the snowplow operators when they are plowing the streets, because apparently there are a lot of accidents happening. Even though the snowplow operators pretty much memorize their routes, there may still be like cases where it snows a lot and it covers, I don't know, a fire hydrant on the side of the street or a parked car and all that stuff, and or sometimes because of exhaustion or whatnot, they forget to lower the bed because every once in a while they have to stop and raise the bed to shift the salt and all that stuff, right? They forget to lower it, and as a result, they kind of tear the power lines, right? So a lot of nasty accidents happen if their blade angle matches the railroad crossing angle. Guess what? Like they just like get stuck there and tumble the entire vehicle. So a lot of interesting cases. So we helped essentially build a mapping system and an augmented reality system for them, where we would take the vehicles out on the snowplow routes to collect data and build a map of the environment. And then when it snows and covers everything, we'll use the same set of sensors to localize against the landmarks that we've identified. So we would know the location of the vehicle so that we could actually project onto the screen in front of the operator how things actually used to look like, almost as if like we are taking an X-ray. Even though everything looks white to the operator, when they look at the display, they see like the lane lines underneath it, the curb borders, the fire hydrants, power lines, etc. Everything is highlighted with additional markers in an augmented reality setup. So they don't collide with things. They don't, I don't know, tear power lines. They don't knock over fire hydrants, etc. So it was a lot of fun, and I was the lead engineer on that project. So I can share some war stories with you on that front. But even 6-7 years ago now, we were able to apply some of those prediction and localization and augmentation kind of technologies to assist the operators to become safer. So maybe some of those bits and pieces can be applied to your business as well.
Well, yeah. So I mean, the last thing I'll say, and then we'll get off this, but my guess, most people that tune in are kind of in the similar space as me. So this is good. This is good for the people listening to the show. So it's like here. So like I hear the fact that you have a forklift, right? How much weight can the forklift lift? Like what's your capacity to be able to lift?
We actually have different models in our product portfolio. We are starting with a 2-ton capacity pallet jack. But on our product portfolio, we also have stackers that can lift up to 1.5 tons and to 2.5 meters. I'm speaking in metric terms, but conversion should be easy. And we'll also be introducing, I guess around next year, a reach truck that can take the loads much higher and also kind of do double shelving, like two pallets deep kind of shelving as well. But at the moment, the product that we are deploying has a capacity of 2 tons.
So how long do they run? How long can they operate?
Their battery lasts around 7 hours. It's a lithium-ion battery, and they can also make use of opportunistic charging. So whenever they have some breathing room in between tasks, they can stop by their charging station, suck up some juice, and then continue their operation. So thereby, we intend to keep them operational 24/7.
Is it doing inductive charging, or is it basically pulling onto like its own little dock, like docking up, taking charge, and going?
Yeah, so at the moment we have a charging station at dock essentially that the robots can pull in, and it doesn't require any manual intervention. An automated kind of head kind of comes out of the charging station, touches the contactors on the side of the robot and charges the robot. And in the next generation of our robot, we are thinking of moving to completely wireless induction-based charging. So there's going to be no moving parts, and the overall setup is going to be much more simplified.
So, because it's fascinating to me, because so one of the things I've been trying to do is I've been trying to make an automatic brine machine. Okay, so in our industry, you said you did some snowplow stuff. So in our industry, everybody's always like, okay, well, how can we plow the snow, or how can we make it safer for the people to plow? But there's a lot going on in the space with putting down salt brine because it's less corrosive. You use 70% less solid. It's better for the environment, and it's easier to apply as far as metering goes. So then my automation brain says, okay, the easiest de-icer to apply would actually be liquids because you can meter it, right? And you can have a controlled speed. You know how many gallons per square foot you're going to put out with the nozzles. You'd be able to test flow. You could probably put a flow tester on each nozzle to know if you have a clogged nozzle. There's all sorts of stuff you could do. So then I look and say, okay, you have a forklift. It's operating in all these places. It can carry 2 tons. I could literally put 2-ton totes out in a parking lot that are already pre-filled. All we have to do is tell the robot what tote to go get into. It lifts up, the boom's attached to the tote, and wham bam, we're in the automated snow removal space with product you already have. And this is the whole reason I do the show, because one day I'm going to say this out loud and somebody's going to be like, yeah, Joe, we should try that. Because, it's a $25 billion space, it's snow removal. And no one's trying to automate it. It's like, I feel like it is my purpose to get someone like you and be like, yeah, I think we should try that, But then it's like, because it would be able to be used without it actually precipitating.
Yeah, yeah.
You know,
So again, we talked about a bunch of different things. So I'm going to pull a few nuggets from those sentences. Like I talked about technology nuggets. I talked about being able to adapt them to different applications as well. And also I talked about some of the bits and pieces of technology being available today to make those things a reality. So now we will combine let's say locomotion's approach to trucking through convoying, and we'll get the snow plowing task and apply to this robotics and automation technology. And actually, there is a concept called tandem plowing. I'm sure you are familiar with that. And some automation is already being tested in more controlled kind of closed environments like airports, for instance.
yeah,
So when it snows a lot and covers the runway, you deploy a bunch of snow plows. Maybe the first one is actually only human operated, and the tandems are all robots, and they tandem plow together to get the runway clear at the minimum amount of time. So maybe the next natural step will be to actually extend that technology to public roads instead of just like doing private runways and such. You'll also be able to do interstates and whatnot. And when it comes to spraying and being intelligent about where you actually and how much you spray, I can pull examples from some other past projects that we did back at NREC, but I was not personally involved. Again, in the agriculture space, we built autonomous tractors for John Deere, for instance, and whatever implement you actually put to the back of the tractor, the autonomous tractor would be able to just like drag it around and such. One application area was of pesticide spraying for orchards. So traditionally, you just literally like spray and pray, and in that kind of process, you lose a lot of pesticide and you damage the environment unnecessarily. You kill other stuff as well. So some form of like precision spraying was a need. And when you have a robot who knows its location through RTK, for instance, very, very precisely, and who can also sense the orchard, like the plants around it, the bushes and the trees, and extract their exact geometry, then you can control that spray implement and each of the nozzles accordingly to just like literally precision spray around the geometry of the plant and never waste like a drop of pesticide. Don't kill unnecessary, I don't know, wildlife and don't contaminate other plants as well. So you can apply that kind of precision spraying to your application. And also, again, knowing where your vehicle is from the GPS RTK readings, you can also start and stop spraying or salt disposal or whatnot in a very precise fashion. So in that snowplow program that I mentioned, that was one of the things that we were trying to achieve, because apparently when you are going over bridges and such, if you just spread the salt in a non-controlled fashion, some of that salt ends up in the water and the river, and that actually is a contaminant. So that actually kills that local wildlife. So that's why when crossing the bridges, you would either like tune down your spraying or like stop it altogether. So you avoid the potential danger of adding some contaminants to the river. And that would be done through like checking your GPS location against the map when your robot localizes to understand that you're actually at the moment going over a bridge. So you should stop spreading salt. And then once you are done with the bridge, then you can resume your operation. So there is all those kind of applications that can be directly plugged into your solution as well, and to make it more efficient, make it more environmentally friendly, and also more cost conscious.
It's amazing because like you're really one of the first people I've talked to that's actually tried to do something for snow removals. But it makes sense because with the locomotion stuff and the trucking stuff, I mean, it all ties in. they're jobs that are hard to staff. It's hard to find people to do it. It's all fun for the first few hours. Like everybody thinks it'd be cool to drive a semi for a few hours, but when they have to do it
Yeah.
all the time, then they have to know they have 80,000 pounds that they're responsible for, or 100,000, depending on the area. All of a sudden, they don't like the stress. Same thing, snow plowing, you know. So yeah, it's quite interesting because we are very similar. We're two people trying to kind of basically automate spaces that people don't want to work in, and it always amazes me. And I guess we can kind of close out a little on this, and I can get more into your personal backgrounds because we've already been on for an hour, which is amazing, I think. But the it's like everybody is always taking guys like us and be like, "Oh, but you're taking people's jobs," and I'm always so frustrated because I'm like, you have an opinion, but you're actually not hiring in that space, right? So it's like we've moved into this world where the world has gotten to a point where it's like everybody's entitled to their opinion. But lately, I'm like, no, people should only give their opinion in a field they actually have the background in, because now in our world of social media, too many people are allowed a platform to give opinions based on nothing factual, you know?
Yeah.
So do you have any metrics on the shortage in the space you're trying to solve? Like what is the labor shortage? You know, do they need 30% more operators, 50%? What is the percentage of shortage?
Yeah, to the best of my recollection, at the moment, there are at least like 60,000 or 70,000 open positions in the forklift operator space. Like they are short that much. And a more specific example, we recently had a conversation with literally like one plant, a rather large company, but one plant with 7,000 forklift operator job openings. So that's one bit of statistic that I can provide. Another bit of information is actually from the Turkish market. Very interestingly, the average number of days a blue collar job posting stays open is 45 days, apparently, in Turkey, while the same statistic for a white collar job is only 20 days. So people are actually looking for operators, looking for someone to do the job, but there are not enough applicants, there are not enough qualified candidates and such. So literally, we are trying to fill the gap. We are not trying to replace an existing workforce, but actually augment them, supplement them, because otherwise they will be shouldering that missing piece, right? So that missing portion of workforce will have to be distributed among the existing workforce, and they will have to work longer hours, they will have to work harder and whatnot, just to satisfy that gap and essentially address that offset. Whereas if we somehow can plug that gap with automation, with robotics and such, all of a sudden they will be working again humanly hours, and they will even perhaps get salary increase and such. That was our model with locomotion as well, because again, when you make robots and humans partners in a task, like truck convoying, for instance, they share the duty, they increase each other's productivity and effectiveness, efficacy, efficiency as well. And as a result, the overall revenue and profits actually increase, because you are utilizing the system more of the time, and it's always kind of generating money for the owners of the let's say the carrier company. And those additional revenues could very well be distributed among the existing workforce, and increasing their income, increasing their overall quality of life by speeding up operations again through that kind of human-robot collaboration. The drivers would be back home more often. They would not have to disappear for weeks at a time, and as a result, again, their quality time with their families, friends would actually increase. So it will be like win-win-win for everyone. when you think from those kind of perspectives, all of a sudden, yeah, I mean, it actually makes sense. Why not have a robot assist me, right? So it's definitely not stealing my job. It's actually augmenting me. It's making me more money. So there's that aspect of it. And another aspect is, I mean, throughout history, it's always been the case when a piece of technology kind of displaces a workforce, not eliminates, but displaces, right? So I always give the example of Pony Express. So there used to be a whole ecosystem around carrying mail via, I don't know, horses and carriages. So there were the horse riders, there were the horses, and then the carriages, and then stables along the path, and some motels and some, I don't know, restaurants and such. So when Telegram happened, all of those things actually disappeared. But those people did not actually like vanish. Their jobs also transformed. Like some of them became Telegram operators, right? So, and when we introduce robots, maybe some of those people are going to be robot operators, robot supervisors. There's going to be some new jobs created, better conditions, higher paying salaries, and such.
That's what I was going to say. In the 7,000, so if you were to fill the 7,000 positions open in that warehouse, how many white collar jobs would you produce? And not only white, blue collar too, because you got to build your machines, right? So if you landed that contract and got all your equipment in there, how many people would you have to hire, do you think?
As like robot supervisors and such?
Well, yeah, for your company, because you do it as a service. So
Yeah,
you'd have to get the
indeed.
machines, build the machines, put them out. How many people would you need to support your product for that warehouse?
Yeah, I mean, definitely not 7,000, but it's definitely going to be in the dozens.
Right.
Yeah,
So, but dozens of people that love their job and they can do it safely, and they'll refer that job to a friend. You know,
right.
it's so quaint. It's so like my daughter works with me. She's my COO at AOS, and when you talk about even like equality and getting different people into the workforce, there's a lot of women that don't want to do blue collar work. But I'm finding in automation, I attract women like crazy to the space because it's very intellectual. They can think about it. A lot of the things actually in automation, the equipment's not as big. It's harder to get into some of the spaces. So my female technicians, their hands are smaller. They can get in places. And I'm 6'4". I'm a big dude, and I can't get my hands in half of the places in these robots that they can. Right, so it's like it opens up an entire new like opportunity because even when you're repairing electric robots, they're cleaner. It's not as
Yeah.
dirty. You don't go home and smell like diesel fuel. You're not getting all the oil. You're not getting brake clean all over your hands because you're spraying stuff down because you have hydro leaks. So I mean the benefits are just massive. And I think what you're doing, it's a rocket ship. I mean, I can't imagine, you know, like where do you see the future going for Atlas? What do you think?
For Atlas, essentially, we would like to have all the forklifts at one point will be automated. So that's inevitable. And we would like to see Atlas owning all of those forklifts. But also, as I said, we are a solution company. We are not necessarily like building just a forklift and asking our customers to make best use of it. We are one of our dear friends and former colleagues and current colleague as well likes to say, usually people are interested in, let's say, having like a quarter-inch hole on their wall. They are not interested in whether you actually use a quarter-inch drill bit to get that hole, or I don't know, some other way to drill that
Just a
hole.
finish
They
nail.
are
Yeah,
interested.
whatever.
Yeah,
Just put the hole
they're
in.
interested in
Yeah.
that hole itself, right? So how are you getting that hole on the wall is your business. The customer is interested in the end result. So whatever additional technology is required to get their job done in a more efficient, cost-effective, safer kind of way, we are up for it. And I see Atlas being the lead in that kind of space because we are rolling up our sleeves and running to the problems that we see that are actually kind of creating the solutions of which will actually create value.
I love what you just said about the quarter-inch hole because in my space when I'm trying to convince people to automatically mow grass. People are like, but what if my customer doesn't want me to use a robot to do it? And I'm like, at the end of the day, they're paying you to cut grass. They're not you should not allow them to tell you how to do it. If you want to cut it with a pair of scissors and take a week to do it, as long as you build on the same amount of money, they really shouldn't care, you know? And I feel like so many people they get too worried about people worrying about how they're gonna do it. But you hit it on the head. If if the scope is put a hole that's a quarter inch in a wall, it should make no difference. At the end of the day, if
Yeah.
you put the hole in the wall, you should get paid for it. So I love that you said that. I just wanted to expand on it for all my end users of automation that are in my space. Just remember that. Use that with your customer. So real quick, I think that we've talked about automation to the point where people probably are like, all right, we get it. But tell me about, I always like to know people like yourself that have an entrepreneurial problem-solving spirit. You know, tell me what you did as a young boy and a young man. It's like I know for me, I used to sit and play with Tonka trucks in my backyard, and now I have a lot of full-size Tonka trucks. So just kind of tell me about yourself as a younger you. You know.
Yeah. So as I said, my brother has been a huge role model for me. So he's been running 5 years ahead of me in age. But we've always had the chance to work together, collaborate on stuff. So he first fell in love with computers, and we had the opportunity to have one of the simplest computers that you could ever have, Sinclair ZX Spectrum. Again, nowadays the current generation is quite spoiled with all those fancy GPUs and CPUs and such. That computer had only like 64 kilobytes of memory. So you had to be really, really creative in your programming to get it to do something meaningful. So maybe starting with that kind of very restricted, very constrained computer also formed our thinking around making things more efficient, kind of working under extreme constraints and still devising a solution to the problem. So that's how we started tinkering with computers, and that's where most of our times would be spent. Occasionally playing games as well, but eventually trying to make our own games, our own programs, and graduating from those rather static creations to more intelligent thinking for itself kind of computer programs as well. That was our introduction to artificial intelligence, essentially making the software think to a certain extent. And we tinkered with that for quite a few years. And then that started becoming boring as well, because it was still limited to the screen, and you could do only so much exciting stuff with that. And we wanted our programs to affect the physical world as well. That was our stepping into robotics. So we create intelligent programs and put them on some physical bodies and embody those software bits. So they could actually do something in the real world, physical world. So we were essentially writing programs for different use cases, even as teenagers. And whenever we started working on robots, we did some quite interesting things, including making robots play soccer, for instance, against each other. So there's a huge international competition called RoboCup. Maybe you are familiar with it. The goal of which is to, by 2050, have a team of humanoid robots, 11 of them, playing soccer against 11 humans, the latest champion of the FIFA World Cup, and win at the end of the day as a robotic team. So RoboCup actually has a bunch of leagues underneath it. Some of them are about soccer, different types of robots playing soccer against each other. Some are legged, some are wheeled, some are completely simulated. And it also has like search and rescue and at-home service robots, etc., kind of leagues. So my brother and I did RoboCup related stuff for almost 10 years, programmed different types of robots to play soccer against another team of robots. So that actually involves a bunch of high level and low level skills, technical skills, because you need to make your robots individually smart enough and complete in terms of like lowest level control all the way up to highest level perception and cognition, as well as make them coherent and effective as a team. So they need to be able to communicate with each other, coordinate their actions, jointly plan their next steps, etc. And working in rather small teams to achieve that, I was fortunate enough to expose myself to every single aspect of that project as well, and that expanded my my breadth essentially in the field of robotics. And then during graduate school, we worked on some service robots who would actually greet people at the elevator and take them to whoever they wanted to visit, our professor, our lab, etc., or distribute candy during Halloween, for instance. And then at NREC, I worked on search and rescue robots. Actually, our team, we built the chimp robot, and our team became the third place holder in the 2015 DARPA Robotics Challenge. As a master's student back in 2006 and 7, I was one of the technical leads of the UT Austin DARPA Urban Challenge entry. So before it was cool, I was essentially sitting behind the steering wheel that turned by itself. At NREC, I worked on some of the projects that I already mentioned: snowplow, trucks, Caterpillar haulage trucks. I was building the perception system, especially for harsh snowy conditions. So those trucks autonomously haul earth from like mining sites and such. And they've been in commission for quite a few years now. I worked on some very interesting military projects, some collaboration with Skorsky, making their helicopters fly autonomously. Did some high-speed off-road autonomous robot stuff. Did some industrial automation processes as well for the steel industry. Let's say, did autonomous trucks, now doing autonomous forklifts. I think as a kid, being curious and trying to understand how things worked and how to make them work better, smarter, etc., always kind of impacted our way of thinking and approaching problems in academia as well as in our entrepreneurial journey. During my grad school, I forgot to mention, we also tried another rather naive kind of startup back in Turkey, where we built a bunch of different robots in modules, starting with an omnidirectional mobile base and an articulated upper torso body and an expressive 4 degree of freedom robotic head. And the idea was to be able to commercialize them separately for different use cases, as well as to stack them on top of each other to turn them into like a service robot. But it was more like an academic curiosity than a business-driven venture. And we were also doing our grad studies on the side. So it did not pan out, but we had a lot of fun, built a bunch of cool robots in the process. So yeah, I mean, I think in the last 20, 25 years, it looks like I had a lot of fun. I still am having a lot of fun. I was fortunate enough to work with really smart people, work on very interesting projects, and I'm looking forward to the future. So the future still has a lot of opportunities, and Atlas is just a step into that direction.
Well, that's awesome. I think that usually I ask somebody their legacy, but I think you kind of summed up the fact that you're having fun and that Atlas is a stepping stone into what you do for fun. I want to say it was fantastic to have you on the show. We're at an hour and 16 here, so I think that this is going to be a perfect show. I will tell you that if you have any inroads with the people at Caterpillar still, they should be talking to me to make the systems automatic. They can follow my 150 employee company around, and they can put all the sensing devices on loaders that they want, and just bring it all in so we can do this. So if you have any ties, I'll say it right on the show. But send them this podcast. Let's get it done. You know.
We'll do.
So,
We'll do for sure.
awesome. I want to tell you, I really appreciate you being on the show. Hopefully, it was worth that over hour of your time. It was definitely worth it for me.
Absolutely. Thank you so much for having me. I had a lot of fun.
Awesome. Thank you. So, Automating Success listeners, we're done. Thank you very much. I appreciate you guys listening and tuning in, and see you next time.